In this video, we are going to take a look at rational expressions. We have examples across the top of the page here of three rational expressions, but rational basically means fraction. So when we talk about rational expressions, we're talking about the quotient or division of two polynomials. Um, Rational expressions are described in the same way as rational numbers, and again, that means they're described the same way as fractions. So we can talk about the top of a rational expression, and when we talk about the top, we would call that the numerator. So the numerator of that first rational expression is x cubed plus 1. And when we talk about the bottom of a rational expression, we talk about the denominator. So the denominator of that first rational expression is x. We can talk about simplifying or reducing rational expressions, and you can see here it says that a rational expression is simplified or reduced when the numerator and the denominator contain no common factors. And we're going to look at reducing those in a minute. Very important statement right here. The denominator of a rational expression can never be 0, and that is because we can't divide by 0. Okay, so that means since rational expression is really a division, we cannot have the bottom ever be equal to 0. And we're going to look at that in a minute too. Okay, so let's look at a couple example problems. In this first set of problems, all we're going to be doing is plugging in a value for x into a rational expression. So here we have x equals 5, and we want to plug that into our expression. So we would have 3 over 5 minus 4, or that's equivalent to 3 over 1, which is equal to just plain old 3. So if we were asked to plug in x equals 5 to that first rational expression, we would get an answer of 3. For the second one, we're going to plug in x equals -2. Be careful, you have to plug it in everywhere you have a variable. So we'd have up top on the numerator -2 minus 3. In the denominator, 3 minus, be careful with your signs, 3 minus a -2. So there you can see if we simplify the top, -2 minus 3 is -5. And we simplify the bottom, those two negative signs or minus a negative, we can do a little chop there. That becomes a plus. So 3 plus 2 is +5. And when we reduce that, -5 divided by 5 is equal to -1. There's the answer for our second one. And for our third one here, this time we're plugging in y equals -3. And again, we want to plug it in both places we see that variable. So up top, we have 4 times -3. On the bottom, we have -3 squared. Be careful when we're squaring a negative number. We do need those parentheses to make sure we do our arithmetic correctly. Up top, 4 times -3 is -12. On the bottom, in the denominator, -3 squared is 9. So I don't know if you can see what's coming here. What do we have in the denominator? We now have -12 on the top over 0, which we said cannot happen, cannot be done. This is not possible. So that means for this answer, we would either say that this one is undefined, or you might say no solution. Okay, that one is undefined because we can't have a 0 denominator. Okay, in our next set of questions, we have different directions now, so take a look here. This set of examples says find all the numbers, and when they're talking about numbers here, they're talking about x values. Find all the x values for which the rational expression is undefined. And what did we just say about undefined? Undefined happens when the denominator is equal to 0. Okay, so for each one of these, we just want to figure out which x values would give us 0 in the denominator. So we take that denominator and set it equal to 0, and that will give us a little equation here. So to solve this one, we just have to add 4 to both sides. We find out that x equals 4 is the value that would give us an undefined rational expression or a 0 denominator. Same thing with this next example. We take the denominator, set it equal to 0. Subtract 7 from both sides. Divide both sides by 3. And we get that x is -7/3. That's the x value that would give us an undefined expression for number 2. Let's look at number 3, same idea. Take that denominator, set it equal to 0. So our first step here to solve would be to subtract 9 from both sides. Okay, so take a minute. What's the next step there if we're solving? We have x squared equals -9. Well, to get rid of that x squared, we would take the square root of both sides. And if you were to plug this into your calculator, so the square root of x squared is just x. But if you try to do the square root of -9 on your calculator, you're going to get a domain error. So that is not possible. There is no solution here. Or you could say it's undefined. So that means, what was the question? Find all the numbers where the rational expression is undefined. There are none. There are no x values that would make that expression in number 3 undefined. No matter what we plug in there, it's never going to be 0. Okay, let's look at this next row of questions. Same procedure, except now we just have a little bit more we have to do to solve. We take that denominator and set it equal to 0. Okay, so that gives us a quadratic equation in this case. There are a couple different methods to solve a quadratic equation, but for this example, I think we should give factoring a try. So x squared is x times x. 6 could be either 2 times 3 or 1 times 6. They both can give me 5, so I'm just going to try one out here. What if I tried a 2 and a 3? To get a positive 5 in the middle, it would have to be +2 and +3. But check it, positive 2 times positive 3 gives me a positive 6, not a -6. So that one doesn't work. That's why we call this trial and error. Let's try again. So 2 and 3 seems no good, so let's try 6 and 1. Okay, to get that positive 5 in the middle, we would need a +6 and a -1. And double check, does that give me a -6 for my final term? 6 times -1 is -6, so yes, that works. Once we have it factored, we take each factor and set them equal to 0. And those are quick solves. On this first one, we just subtract 6 from both sides. And we find that x equals -6 is one of our solutions. On this other factor, just add 1 to both sides, x equals +1. So this rational expression would be undefined if x was either -6 or +1. Okay, number 5, take that denominator, set it equal to 0. Again, we'll try to factor because this is a quadratic. It's got an x squared in it. And this is one of our special factoring formulas you should recognize. This is the difference of 2 squares. So it factors into x minus 7 times x plus 7. And then from here, same as last example, take each one of those factors, set them equal to 0. For this first one, add 7. It's already a minus. We'll add 7 to both sides, so we get x equals +7. For our second factor, we'll subtract the 7 to move it over, so we get x equals -7. So again, there are 2 x values that would give us an undefined rational expression for number 5. Okay, and then this last one, number 6, same procedure. Write out that denominator, set it equal to 0. This one maybe takes a little more thinking to factor. People have a lot of different methods for factoring an expression like this. There is no GCF, there's no greatest common factor, so that means we just have to try to factor this trinomial. Sometimes this is the procedure that a lot of students use. 2 times 7, so the leading coefficient times the constant. 2 times 7 is 14. And the middle, or the coefficient of the x term, is -9. So I am looking for 2 numbers that when I multiply them together, they will give me a 14. And when I add them together, they will give me -9. So 14, 2 times 7 seems like a good idea. And to get a -9, that would have to be -2 and -7. That also gives me my +14, so that works. So next step, when we're using this factoring method, you could do bottoms up or slide and divide. I'm just going to go ahead and write it out to factor by grouping. So what we do next is we take that -9x and we split it into the 2 numbers that we found over here, -2x, -7x, and then we still have the +7 at the end. Once we write it out like that, we split this in two and we factor by grouping. So out of those first two terms, I can pull out a 2x, and what's left behind is x minus 1. From my last two terms, I can pull out a -7. What's left behind is again x minus 1. So that means we have factored this into x minus 1, because those two common factors we're going to pull that out front like a little GCF. And then what's left behind is 2x minus 7. And to kind of continue here on the next page, because I ran out of room, take each one of those factors and set them equal to 0. From our first factor, we just get the solution that x equals 1. Over here, we can add that 7. I'm going to scroll down because I'm running out of room, sorry. And then we'll divide both sides by 2. And that means x is 7/2. So for that last example, number 6, there are two x values that would give us an undefined rational expression, x equals 1 and x equals 7/2. Okay, in this next set of problems, we are going to look at how to simplify rational expressions, or how to reduce them to the lowest terms. It says here, a rational expression is simplified to lowest terms by factoring. So important. Factoring is like the magic word in algebra. We should always be trying to factor something, it seems like. So we can simplify by factoring the numerator and the denominator completely, and then dividing out or canceling any common factors. Okay, so they gave us an example here. If we have a numerator that was p times r and a denominator that is q times r, those r's that are common factors, they cancel each other out, and that is equivalent to p over q. So let's take a look at some of these examples. Remember, I circled it in red up here, factoring. That's what we want to do when we see a problem like this. So this first one, how can we factor the top of that, the numerator? Well, 3 and 6 share a common factor. We can factor out a GCF of 3. When we do that, what's left behind is x minus 2. And in the denominator, 4x and 8, well, they share a common factor. That would be 4. What's left behind is again x minus 2. So you can see now that we have things factored and we have everything up there is a factor, not a term, we can cancel those two common factors, and we find out that this rational expression is equivalent to 3/4. Okay, it is important to factor. You cannot, if we had something like this, 2x minus 1 over 2x plus 7, you cannot cancel those two x's. Notice this is not factored. These are two separate terms on top. It's only when we have multiplication up there, not when we have addition or subtraction. So there's no reducing to be done on a problem like that. So make sure you factor first. Okay, this example number 2, that's nice because it's factored for us already. And if you look at the numerator and the denominator, you can say they both share an x minus 3. So this rational expression is equivalent to x minus 8 over x plus 2. Okay, next up, number 3, we need to do some factoring here. Negative 2x minus 10, well, they both have a factor of negative 2. When we factor out a negative 2, it changes those signs. And now we can see that we have an x plus 5 on the top and on the bottom. So we will cancel those. That gives us negative 2 over 1, or just equivalent to negative 2. Number 4, maybe at first glance you might be thinking that one doesn't really look like it factors, but there's kind of a little trick we can use here. Notice that we have the same terms on the top and the bottom, it's just that their signs are different. So what we can do is on the top, let's factor out a negative 1. If we do that, 7 divided by negative 1 is negative 7. Minus x divided by negative 1 becomes plus x. And then we might not quite be seeing it yet. Let's go ahead and do one more thing. Up on the numerator in the top, let's reorder those two terms. So let's put the positive x first and the minus 7 second. And then once we finally have it written like that, you can see we do have two common factors, x minus 7 on both the top and the bottom. So there is our simplified expression. That whole expression is just equal to -1. Okay, number 5 and on, we get into a little heavier factoring. We have to factor both the numerator and the denominator here. So looking at that numerator, x squared becomes x times x. 4 could either be 1 times 4 or 2 times 2, but to get that middle term of a 3, I think we're going to need a 4 and a 1. 2 and a 2 can't give me 3. So it would be a +4 and a -1 to get that 3 in the middle. In the denominator, we'll factor x squared goes to x times x. 8 could be 2 times 4 or 1 times 9. I mean, sorry, 1 times 8. But to get that 9 in the middle, that's what I was thinking of, we're going to need an 8 and a 1. And if it's going to be a -9 for our middle term, they are both going to have to be negative. And just quick mental check, does that work? -8 times -1 does give me a +8, so that's good. Okay, here we ended up with an x minus 1, both in the top and in the bottom. So our simplified expression would be x plus 4 over x minus 8. Again, we can't cancel those x's. Don't do it. I know canceling is fun, but you have to draw the line somewhere. You cannot cancel those x's because they are terms. They are not factors. They are added and subtracted, not multiplied. Okay, let's take a look at number 6. Again, try to factor, see what you can do. If we look at the numerator of number 6, we have a GCF of x. What's left behind if we factor out an x is x minus 1. On the bottom, we also have a GCF. We can pull out an x again, and what's left behind is x plus 9. And now again, once we factor, we see those common factors. We can cancel those out. So this is equivalent to x minus 1 over x plus 9. Number 7, you got it. Let's factor. The top is the difference of two squares. So that's x minus 4, x plus 4. The bottom takes a little bit more thought. X squared, we split that into x times x. 28 has a few options, but I'm thinking 4 times 7. That will give me that 3 in the middle. Since it's a -3, that means I need the -7 and the +4. Double check. +4 times -7 is -28. That works. So let's see what cancels here. It looks like the x plus 4s cancel. And our final answer, x minus 4 over x minus 7. Careful on your signs. Okay, you might want to pause here and try the next 4 on your own and see, then check your answer with my work. I'm going to keep on going. Again, factor first. So up top, oh, look at that. Be careful. What's going to make that easier to factor is if we pull out the GCF first. Don't just jump into factoring that trinomial right away. All 3 of those terms share a common factor of 3. Bottom is the difference of two squares. Sometimes I put the plus first and sometimes I put the minus first. It doesn't matter. So we got to factor again on the top. We're not done yet. X times x, and factors of 10, how about 2 and 5? How can I get a -3 from a 2 and a 5? Well, a -5 and a +2 will work. And then once again, the fun part, cancel those common factors. There we go. And our final answer would be 3 times x plus 2 over x plus 5. Okay, number 9, let's factor that numerator. 24, I need factors of 24 that are going to give me a -10. Well, 6 times 4 is 24, and if they are both negative, I get a -10. Now stop for a minute here. 6 minus x, again, doesn't look like it factors, but remember that trick we used back on, what was it, number 4 or something? I can't remember. If we changed the signs of both of these terms, it would match one of our common factors. So I'm going to factor out a negative, and that's going to become -x plus, sorry, -6 plus x. Or if I were to rewrite it in a different order, You can rewrite it as long as you keep the sign with each of their correct terms. So it's a plus x, so that's positive, and a minus 6. And then again, when we write it like that, boom, boom, those two cancel each other. And we get x minus 4 over negative 1. Or we could, a negative 1 on the bottom can really, the sign can just go out front. It's just dividing by a negative 1 is the same as multiplying by a negative 1. So there's our simplified answer. Okay, 2 more of these. Again, factoring is your friend here. We got a factor. This one, I might run out of room here. Let's see what we can do. To factor the numerator, 4 times negative 6 is negative 24. So I'm looking for 2 numbers that will multiply together to give me a negative 24 and add to give me a positive 23. So that's going to be 1 times 24. And to get a positive 23, I need a plus 24 and a minus 1. So for my numerator, I'm going to have 4x squared minus x plus 24x minus 6. I'm going to go ahead and keep working my way through the numerator, then we'll do the denominator, and then we'll put them back together. So again, factor by grouping, pull out an x, and pull out a 6. So that numerator factors into 4x minus 1 and x plus 6. And then we'll do the denominator right here next to it. So 12 times negative 4 is negative 48. And our inner term is 13. So I'm looking for factors of 48 that will add to 13. I should have done this in advance because I don't like to do math in my head. It's not 6 times 8. Let me see, I'm grabbing my calculator. You're allowed to use your calculator. There we go. 3 and 16. Yep. So 3 and 16, if I have a minus 3 and a plus 16, that gives me that positive 13 in the middle. So again, I'll rewrite the denominator, 12x squared. But instead of plus 13x, I'm going to write it as minus 3x plus 16x minus 4. Factor by grouping. So in the first 2 terms, I can pull out a 3x. And from the second 2, I can pull out a 4. And then it finally factors into 4x minus 1 and 3x plus 4. And now we got to put it all back together. Okay, so I'll go to black, I guess. So remember the work I had in blue over here, that was our numerator. And the work I had in green over here, that was my denominator. And now that we have it all back together, I can cancel those 2 common factors. So our final answer is x plus 6 over 3. Oh, that's a bad 3. Oh, well, you get it. 3x plus 4. There's our reduced, simplified rational expression. I'm going to go ahead and skip number 11 because I ran out of room and we've done a bunch of those. So hopefully you guys are feeling pretty good. Okay, now we have a word problem with a rational expression. And look at those cute little bugs we have going on here. Suppose that an insect population, so maybe we're talking about the number of grasshoppers, okay, who knows what. The number of grasshoppers in thousands per acre is modeled by P equals 5x plus 2 over x plus 1, where x greater than or equal to 0 is time in months. So x is going to be the number of months, and if we plug a number in for x, that'll give us the number of insects that are in this field. Okay, so first thing we want to do is plug in 0 for x, and that will tell us how many bugs or how many insects we're starting with. So 5 times 0 plus 2 over 0 plus 1. Well, that's just 2 over 1, which is just 2. Now remember, be careful, it says P in thousands. So the answer we're going to write in there is just 2. But remember, that really means there aren't 2 bugs, there are 2,000 bugs, okay, because we're measuring in thousands. Okay, then we want to plug in 12 next. So we would have 5 times 12 plus 2 over 12 plus 1. And again, I'm going to grab my calculator. 5 times 12 plus 2. That's 62 divided by 13, which is 4.769. It doesn't tell, oh, it does say round to 3 decimal places. Oh, make sure you always read your directions. So for this one, we would fill in 4.769. So that would be 4,769 bugs. Okay, then we'll plug in 36. And there we get 4.919. I'm going to round that last digit because it asks us to round to 3 decimal places. And finally, we'll plug in 60. And we get, oh, let me clear it out. I messed up on my calculator. Hold on. 5 times 60 plus 2 divided by 61. We get 4.95. Again, we're going to round 1 because it's 0.8 on my calculator. I only want 3 decimal places, so I'm going to round to 4.951. So question number 8, part A was complete the table. Part B, what is the initial insect population? Well, the initial would be when time equals 0. So it was 2,000 insects when we started. Interpret the results in your completed table. Well, you can notice that if we look at these numbers, they are getting bigger, but they're not getting too much bigger. Like as the number of months go by, this number is getting, it kind of looks like closer and closer to the value 5, right? So you might say the number of insects is nearing 5,000. Okay, and that's it for this video on rational expressions.